Hello, right now I'd like to make a brief follow-up to notes on my theories of the universe, which is itself an addendum to the 2019-2020 discourse of mine entitled simply My Theories of the Universe. So, to summarize, my theories of the universe was basically a series of recordings that I made, well, primarily two recordings. The first in 2019 at the latest, and the second in late 2020, which cover ideas that I have regarding metaphysics and cosmology. Now, my knowledge at the time of my Theories of the Universe Part 1 in 2019 was incredibly limited, and I did not yet have a grasp on basic classical mechanics, let alone the mathematical frameworks necessary to understand quantum theory and modern cosmology, which was a lot of what I was describing. And so I came up with three basic theories at the beginning. Now, in my Theories of the Universe Part 1, these are as follows. So the first is, generally, the theories are, there is an infinite number of universes. The second, I believe that each universe itself is infinite in size. And the third, I think, is a logical result of the first two, that because you cannot have multiple universes which are all infinite in size occupying a space that is next to one another, because if you kept going you would never be able to reach the end of one universe. They are all superimposed, essentially, and they are all occupying the same exact four-dimensional brane. That's a brane in space-time. And so these theories were what I had, and next I started trying to reconcile the idea that the universe began a finite period of time ago with the apparent understanding that it is infinite. And I utilized the concept of asymptotic growth to explain this, although I didn't call it that at the time. But that's generally the concept that I was using to kind of square away these issues. And that was my general stance, along with a lot about time travel and the organizational structure of the universe, and how the universe might have to exist in a set of groups in order to make multiverse or even an omniverse possible, and kind of just using the logic and semantics of that somehow arrived at the conclusion that there were four universes from which I derived that, based on infinite math, a lot of it conceived by George Cantor, that there were multiple levels of infinity, and that the universe existed somewhere along the spectrum. Now, there is a key concept that I touched on, I believe, very briefly at one point in my Theories of the Universe Part 1, which is that every single change in the universe causes what's called a universal diversion. And this essentially means that it splinters into two distinct realities. One in which the change went one way, essentially saying that something could happen at any time, in the other in which it happened differently. Now, one thing that I believe in my Theories of the Universe Part 1 that makes this incredibly difficult to establish a multiverse this way, which is interesting because it was kind of like I started off with the idea of a multiverse, and then afterwards I explained why there would need to be a multiverse in the first place, rather than starting with the problem and then resulting with a theory that there is indeed a multiverse. And so the problem with this was that I believed that space-time, at the time I recorded my Theories of the Universe Part 1, was completely discrete. That particles, quantities, forces, amounts of mass and energy are continuous, and that space-time itself is continuous, which means that theoretically there is no smallest distance, and particles could be created at any point, at literally any point, and that particle diversions, as I call them, or basically if a particle decays or if it reacts with another particle, could happen at any time. So that means that within a finite, if a universe is even, if it even has a finite amount of space and it exists for a finite amount of time, there will necessarily be an infinite amount of universes that generate just from that, because within the finite amount of time, there are an infinite amount of times when the universe can diverge, and within the amount of space, there are an infinite amount of coordinates or positions at which those interactions that caused, the universal divergence or diversion can happen. So this created a lot of issues, and a lot of these issues were resolved in my Theories of the Universe Part 2, which is a drastic shift in theory that was created around late 2020, and I pivot to an understanding that there are, in fact, that the universe is finite in size, that there are a finite amount of universes, that space-time is discrete, and that our current universe has only existed for a finite amount of time, and that essentially this branching possibility of universes happens at discrete moments, which is to say my understanding that there is a smallest space and time, which is informed by the concept of the Planck time. Now, I did not understand where the concept came from. I understood it then and largely still today as a purely theoretical concept rather than something for which I have rigorously sought to understand its mathematical foundations. So this essentially resulted in an understanding that I espoused in which there were these kind of, the universe at the quantum scale was actually discrete, and that it was made of what are essentially pixels. And that within each of these pixels would be housed different particles. There would be a fundamental particle which would kind of kick off the universe. It might move to different places, it might decay in different ways, and from each of those, it might split, it might create a second particle, it might interact with the first, and it would kind of create this almost family tree of sorts with all these different potentials for different particles and moving outwards from the center of the universe in different ways. And this would create a tree. Now, if you know anything about modern cosmology, you are probably thinking that instantly right now, this is almost identical to two theories, which are not mutually inclusive, I should say. One theory does not guarantee the other. Now, these two ideas are those of the many worlds interpretation of quantum physics and loop quantum gravity theory and the associated loop quantum cosmology, which applies those principles to a broader scale of the whole universe. Now, I did not know what either of these were, and I did not know that they existed, especially loop quantum cosmology, up until 2026, which is the time of this recording. But in 2019, a friend who I showed the current state of my Theories of the Universe Part 1, which I believe I just finished recording, or I was in the process of recording, explained to me that the many worlds interpretation already existed. So that was not something that I came up with for the first time, though I did develop the idea independently. It's just that mine was a personal conception of the universe and not something which was created based upon an established mathematical framework. And so these two ideas came together to govern my understanding of the universe. So I'm going to add a note here, which is that one major principle of modern cosmology that I did not understand at that time, there is the issue of curvature, intrinsic curvature, and extrinsic curvature, and the two types of curvature, both of which I believe are intrinsic, which pertain to three-dimensional space, one of which is affected by the particles which exist in matter, and the other one is just a fundamental property of geometry that defines the universe, and that those are separate themselves. So those are things to take into consideration. Putting all of that aside, one thing I didn't understand was that no matter the shape of the universe, even if it's finite, which current physics does propose is possible, that it's what's called open-ended. And now this is crazy to me because even though the idea of curvature based on a constant which would shape the expansion and possible contraction of the universe, and it pertains to the energy density throughout the universe, even though that expansion is continuing at a certain rate, the problem with understanding it in this way was that I believed that there would be a certain edge to the universe and that it would function in a completely three-dimensional format. Now, one thing that I didn't take into consideration, and I don't know how I could have arrived at this theory, but it was basically the idea that since we know that the universe exists in 4 dimensions, there is an independent variable, which is to say the dimension of time, and that we just perceive differently as the dimensions of space. That means that it is possible for there to be manipulations in the 4th dimension that, of which we may not be aware. And so an example of this is how there is the constant explanation necessary to understand what's called an open-ended universe. So this means that even if the universe is finite in size, essentially, once you reach the end of the universe, you can cross a certain boundary line and it will repeat no matter where you go. And so what came to mind is imagine people are living, say, like a flatlander or something like that on a 2-dimensional plane. Let's just say a rectangle. And if you were to take this and curve it around and make a cylinder out of it, they would be able to continue along that rectangle, go anywhere, a certain direction until they hit an edge, and they wouldn't realize that they'd hit the edge because it would be completely continuous. In theory, they would be able to keep going. It would essentially just appear as if there are infinite universes next to one another, which are identical, but in function, and this is kind of when you get into the whole philosophical understanding of it, they are the same universe. And the idea that, while there are just infinite universes next to one another and they all happen to be identical, versus it is a universe in and of itself, which is just repeating an infinite amount of times, is really just a difference of the vocabulary you use to describe it. But in terms of understanding physical matter, which is finite, and our understanding that 2 particles that exist in the universe cannot be advanced or elaborate structures which repeat essentially and follow along in the actions of other structures based on exact identification with the physical motions which are put into place by those structures completely dependently on one another in real time. So what I'm saying is there is no known law of physics in the universe that dictates that if I am here on this planet and I raise up my hand, for instance, that in another part of this universe, there will be another planet where there is someone who is atomically an exact replica of me who raises their hand in the same exact way that I do at the same exact time, in unison, interdependently. That is not possible. And so the logical conclusion from this would be to result that it is just the same universe, but repeating again and again. And so a better way to visualize this maybe than a rectangular strip of paper curled into a cylinder may be if the rectangle or whatever the sheet of paper is, we might say a circle, but I think that might make it a little bit harder to visualize, is kind of wrapped up into like a dumpling shape, where all of the edges are met at other edges. Now, this would be very hard to create, just given the physical limits of the material, but in theory, it would allow for something that anytime you hit an edge, it would essentially take you back to another edge, and you would kind of come back as in some video games where you can kind of go to the edge of the screen, and then your avatar, your icon will reappear at the other edge of the screen and keep going in the same direction. And so this is the possibility of an open-ended universe. This also solves a major problem that was the kind of what I call the smoking gun in notes, the original notes of, on my theories of the universe. And it was something that I believe still gave a lot of credence to my theory that the universe is infinite in size, which is now no longer necessary due to my current understanding, which is to say that if the universe is expanding, the idea that the universe is expanding is not that it is simply the matter in the universe is expanding into an existing background independent void, essentially, or that space-time itself is extending into a non-existent void, but that the actual fabric of space-time and the density, of particles that exist is what's expanding. The actual geometry is what's essentially scaling up. But the problem with this is that it doesn't appear to be expanding from any singular point, and that it looks like no matter where you are in the universe, it's expanding away from you, which essentially means that every point is expanding away from every other point. Is possible to imagine. Now, the one problem that I can imagine with this in an open-ended universe is that if everything was essentially going towards the edges, that would mean that everything else is coming out from the edges and going inside from the other edges, which would give the appearance that everything is fundamentally shifting by everything else, and that things are moving in two opposite directions, which would give the appearance that some things are moving towards others. For example, if one thing was going towards the edge, one end of the universe, and another object was going towards the other end of the universe on the opposite side, but the first object was, say, moving at a faster rate, or it was just closer and it hit that edge sooner, and then it would basically, in the view of the universe, essentially rematerialize on the opposite side because it's an open-ended universe, so it would just kind of reappear. Now, this is the idea that there is a four-dimensional curve that we can't understand that is perfectly natural, and it's not like it needs to be curved by some higher power and needs to be bent around, but it does create problems with understanding because it would essentially dictate that that there are ways the universe functions that we just can't understand in terms of the current dimensions which are available to us, or three dimensions in an absolute sense, which is why the fourth dimension is necessary to understand this recurrence, or the idea that even if the universe is spherical, or what I would call a 4D sphere, that every point at the edge of the sphere is intimately interconnected with a point at the other side of the sphere, at which they would not function as separate points at all, disconnected from one another, but tied to one another. Just like if you had two edges of a sheet of paper, and you put them next to one another, they would be next to one another in the conception of a three-dimensional being, which is standing outside and looking at the surface, which is visualizable in two dimensions, but to any two-dimensional beings on there which can only see in one dimension, it would appear as if everything exists as it was before, but suddenly the universe would essentially rematerialize as an exact copy of itself on the other side. Now, this does remind me of a planet, actually, I believe, in the story A Wrinkle in Time by Madeleine L'Engle, which is something that I did reference in terms of speculative cosmology and higher dimensional math in my Theories of the Universe Part 1, but had generally, had not entirely forgotten. It was just no longer relevant to my theories by the time I was working on my Theories of the Universe Part 2. Now, sorry if there are some noises, I did have to relocate. But basically the end result of this theory is that there is an open-ended universe, like I said. Now, what's really fascinating is that in loop quantum gravity, loops are the fundamental material of space-time. And they are essentially what I called IIs, or infinitesimal increments, or the pixels that make up reality. So whether you want to call them pixels, loops, or IIs, they're all generally referring to the same concept. Now, there is a bit of a technical nuance that loops, the particles form on the nodes of the loops, and they are interconnected by spin networks. And apparently spin foam is the application when it comes to taking time into account with the spin networks. And essentially all of these nodes and the links between them are assigned specific values and different characteristics that have to do with mass and volume, energy, gravity, and other attributes. And that essentially there are all these different qualities in which they can exist, and those qualities are assigned different quantities. And so my theory was a little bit more in line with the conventional view of quantum physics in the standard model, but the ultimate structure of it still conformed to this idea of loop quantum gravity. So eventually, in loop quantum gravity, there's a principle that because these loops make up the fundamental material of space-time, that essentially reality is not background dependent. What I came to realize very recently is that in classical mechanics, as well as relativity theory, and even the standard model of quantum mechanics, reality is treated inherently dualistically, because even if you are a materialist, and even if you believe that matter is the only quantity which exists, there is still a duality between matter and the space it inhabits. And these are two fundamentally different things. And the idea that space is something. So this is, again, in my potentially somewhat dated theory, which I call the presence of nothing versus the absence of nothing when it comes to eternal afterlives, when there is a conscious experience of nothing that includes time and exists forever, versus no experience, no consciousness, no time, and if you were to apply time to it, it would last forever, because it's the theory that there is no end to it, but because time doesn't apply to it, saying that is kind of irrelevant. It's just the hard stop of consciousness after death. Now, nowadays, I might be tempted to call it a little bit dated, because it's predicated on the idea that in terms of matter and reality, there is, it basically comes from a solipsistic perspective that my individual consciousness is the only quantity that I can verify. And so, to myself, and it's not even a matter of knowing it, it's a matter of being it, essentially. So I am, you could call it self-knowledge if you want to, or create whatever convoluted concept necessary to explore it. But the ultimate outcome is that there is essentially one, what I called perceptive essence, or as I called it on consciousness in the universe for 2022, a point consciousness, but perceptive essence may be a little bit more accurate here. And it's the idea that from that, everything else is determined, and there is no way of determining how that is mediated. It could be through consciousness in the real world. It could be through physical matter, right? And it just arises dependently based on everything that came before it. It could be mediated through a computer simulation, or through like a circuit board. It could essentially be a very complex set of information that is digitally mediated, or it could be created through a framework which is not at all known through the laws of physics that govern the universe today. For example, basically the idea is that it's kind of like a universe where the fundamental nature of reality, or the resulting reality that the reality that results, is completely different from the apparent reality of our universe. Although this is a bit of a paradox because it's predicated on the idea, it must be predicated on the idea that the source is different, and the source of certain concepts in our reality is completely constant and not dependent on the specifics of a certain universe. For example, there are certain levels to this. Like if I'm talking about pi, e, or a mathematical constant, that's going to stay the same no matter what, no matter which universe you're in. And I think that's a pretty generally accepted fact, because they're just constants that exist. Now, there are some problems with this understanding, because immediately necessary is a next level, is a second level of this, which are essentially quantum particles. Now, if we were to say in the Higgs field, for example, the top quark and the Higgs boson are the two particles which are kind of like defined in the index of the characteristics attributed to every other particle. And it is, the kind of nature of reality rests upon these qualities which are intrinsic to those two particles. But next up, there are ideas that things in the universe happen based on specific probabilities, and that is maybe the kind of third level of these universal specificities. And so those, maybe you could even posit at fourth level that things have to happen exactly the way as they do in this universe. And if that's true, that basically disintegrates many worlds theory entirely, because it dictates that because things have to happen exactly the way that they do in this universe, there is no such thing as free will. Everything is predetermined. Things will play out in a certain exact way. That just knowledge is not entirely knowable. It could mean that there is only one universe and its eternal recurrence or eternal return that just continues on ad infinitum, or it could be that some background radiation or other elements of the universe kind of carry on, and at each universal bounce transform the events of the next universe, and so that they are entirely dependent on what happened in the last universe, but they are fundamentally not the same events, which is why this could present the classical Indian idea of kalpas as universes, and they all take up the same space-time. They're essentially a continuity. It's just a time demarcation between one universe and the next based on big balances. But what actually takes place within those universes differs drastically. So this creates some problems to analyze, but I would also say that, maybe there are these 4 levels of universal specificities. If that happens, I don't really see an issue with the 4th level, that everything has to be exactly as it is in this universe. That may be true. But it's interesting because when you look at things at the quantum level, there's this frustrating tendency that apparently, and this is bringing in a whole other level of complexity here, that events do not exactly happen at specific times. They are based on probabilistic quantities, and one of those quantities is the exact time that they occur. So something could happen within the span of a few Planck times, and there is a certain probability, if I'm understanding this correctly, that it will happen at any given time and not at another time at a quantized scale, which loop quantum gravity assumes. And that also, depending on where you are in your perspective, something could appear to happen at two different times. And people are even talking about how, time might move forward or backwards, and that's a theory that I can't exactly claim to understand right now. But the general understanding is that this probabilistic nature of the universe, and a way of solidifying the fourth level of universal specificity, might be that there's the reason why the universe is exactly the way it is right now, and the reason why everything happened the way that it did, is because of a bell curve, and that this is simply the most likely outcome, and that it's almost kind of like a tree, but each of the branches, if we're going along with a tree visualization of MWI, or the many worlds interpretation, that each of the branches dies off incredibly quickly the moment that it becomes improbable. And this creates a theory that, there might be a hybrid between these two theories, that what if these branches are out there, they're just so unlikely that they become virtually impossible to be experienced at all. And if these quantities of probability are quantized, if the measures of probability are quantized, that means at a certain point the universes would just pop out of existence, because they would be so improbable that they would no longer exist. So I think this is really interesting to consider. But this form of a universal tree that I was just describing would essentially be like a very tall pole with branches that are coming off either side at every possible moment, which is to say every Planck time. The result of that theory is that essentially, there's no need for many worlds interpretation. The universe is exactly the only way that it logically would be, and this is coming back again to the idea, the Buddhist cosmology of a linear string of universes that go on ad infinitum, have always existed and always will exist. And it's the one major logical flaw, or at least what seems like a flaw that it may run into, is the question of how it could exist that now is a certain time, and the events that are happening constitute the specificity of this time, essentially, and the fact that it's situated on a timeline of things that happened before and things that happen after it, and that a finite amount of time ago there were events which ultimately led up to what happened now. But if you go back, in theory, there would never be a beginning moment, which absolutely doesn't make any sense. It's like a continual stream that has no beginning. But one solution to this would be that it's the most logical, necessary solution to have a universe where there's no creator God, or no reliance on an explanation of something else which could exist. And it still doesn't clear up the issue of the classic issue of, why is there something rather than nothing? But it would still exist in this way. And it would just have the minor issue of saying that, there would have to be a point that existed an infinitely long time ago. But I think this could be easily averted by dismantling the concern, by addressing the idea that it is impossible for an infinite amount of time to exist. There can be a finite amount of times, but the infinite amount of time is only a theory which is necessary for explaining the reality. Now, if you look at the reality of the universe and you try to look at it in one picture, yes, it would be an infinite amount of time. But because an infinite amount of time is not something that can be measured by definition, there is no point in time that was an infinite amount of time ago. That point in time would be the first time in the universe, and because the universe has existed for an infinite amount of time, there is by definition no first time in the universe, which would mean that that's essentially the solution to this dilemma, that the universe or some iteration of the universe has always existed, and that it's constantly undergoing change, and that it always will exist. Now, of course, there's the specificity of this, which loop quantum gravity asserts that there was a universe before this one, and it just kind of collapsed and expanded, from a big bounce into our universe, which basically means that we are in the second half of a one-time event that happens in an infinite stretch of time, which I think would create the idea of incredible hubris, because there is an infinitesimally low likelihood that we exist as human beings at all, at any planet, at any time, disregarding the idea of, whether there is or is not alien life out there in the universe, or whether we are not other conscious beings on Earth, or whether other beings which we do not consider to have consciousness are conscious. And the specificity would arise as a problem in wondering about why we are situated just enough time after this big bounce happened to be able to live on a planet where things are still coherent, where there is possibility for life, where there are all these things that are happening, and not exist in the comparatively, I wouldn't even say comparatively larger, but comparatively present infinite expanse of cold, basically frozen time that would happen after the current observations of dark energy expand the universe to the point where it would not exist at all, which would basically mean that if you use this model where you zoom out to space-time and you look at the entirety of the existence of a universe from a beginning to an endpoint, even though it basically wouldn't, this theory, it doesn't have really a specified beginning, and that's the issue that I'm about to cover next, but that it doesn't have a specific end time. It basically means that there is a midpoint, and the midpoint is the big bounce, and that on either side of that there's a coherent universe. But as soon as you go forward enough in that universe, it eventually starts to lose coherence, and it results in a big freeze on either side, and that basically the entire timeline is taken up by a big freeze, except for assuming that it's symmetrical, the times right before and right after the big bounce. And to assume that we are living in an infinitesimally small likelihood, of time in which the entire universe would not allow for that, basically means that there is an infinitely low chance that any of the things that are happening right now are happening, rather than an absolute chance, which is what would be guaranteed if there was an eternal cycle of universes, because it would mean that no matter where you are on that timeline, there's always the potential that you can be existing in the universe as a being, because there's always an active universe going on. Now, the problem with this that I was just talking about addressing before was that it doesn't really answer a start to. If we believe that, based on our observations, that dark energy is essentially ripping the universe faster than it can contract, and it's kind of expanding at an accelerating rate, there would have to be, and I forgot the term, I just learned the terms for these yesterday, the first half and the second half of each kalpa. There's the first half of the universe is expanding, and which is strikingly similar. If you look at other creation myths across other cultures, I think I'm just going to take a moment to pause and say that I think it's really fascinating how if you look at these creation myths around the world, there are so many cultures that believe in linear narratives that are driven by agency and driven by action of certain creatures in a way that, say a certain being created the earth, and there was a certain animal that gave rise to the earth, there were different realms, there were different, things that happened, and they were partitioned in a way that's very easily understandable to the human mind, which makes sense because they were created by, early human psychology. But the classical Indian cosmology dictates that, there is not really need to be, of course, there's so many different interpretations of Hinduism, and it's a very diverse religion, but even within Buddhism, there is no need for a creator God, there is no need for an agency outside of the universe. It is a principle of space-time itself, which is the conclusion which has independently been reached by a lot of contemporary physics, or is just implicitly assumed, which is why we need metaphysics to kind of investigate these issues, but it is generally assumed by modern physics. So I found that really fascinating, that there's the kind of parallel between the ancient study and the theory, which is very much alive today in the current understanding of Buddhism and has been for over 2,500 years, but is also an understanding of modern physics. And so the problem, though, is that the kalpa posits that there was a contraction of the universe And this is one of the major issues which has not yet been cleared up, but I'm about to address it afterwards with my relation to the many worlds interpretation, how they could actually go hand in hand, even though apparently a lot of Buddhists today believe that the many worlds interpretation is an expression of the traditional Buddhist belief, even though it is not at all related to the idea that there are universes that are in a cyclical, cyclical might be a little bit misleading, but the idea that it just kind of, expands and contracts and continues infinitely, a progression that doesn't have a beginning or an ending, and that it's constantly just being in the stream of that, then, you could say eternal, but constantly changing and dependent on the thing that happens before, causing the thing that happens afterwards, in some way, then those are unrelated concepts. But I do think they are not mutually exclusive, and I would like to emphasize that. And so I think, that idea and many worlds interpretation. So one problem with understanding the many worlds interpretation is that if we are talking about loop quantum gravity, and the idea that, if we are talking about dark energy, and the idea that there is a force which is ripping apart the universe, causing the expansion of the universe to accelerate beyond what just normal gravity energy density does. If it disappeared, the universe could stabilize, or there might be a potential for the gravity to reverse and essentially cause this big crunch, which is the traditional idea before observations of dark energy were made, which now result in these two other theories, which are the most likely one, which is to say the big freeze, given the understanding of dark energy without the Higgs field, which is just based on empirical data rather than theoretical understanding, or the big rip, which is the violent idea that dark energy is in flux and is something that is itself growing in power, and it eventually will just overcome the fundamental principles of the rest of physics and basically lead even individual, like atoms and possibly even their components, like the elementary particles, to rip apart. And so this is really fascinating to me, but it does pose a number of problems for the idea of the kalpa, because it essentially creates this very deterministic universe where there is a singular time in which any of these things can happen, and that it is infinite, but at a certain point, again, because of the quantization of the universe, assuming that the universe is finite, it basically just becomes frozen, which would ultimately mean that there's no time passing at all and that there's no longer any specificity. And dependent origination just completely stops because there's no longer anything happening and everything is in a state of that it existed because of what was due before, but it can no longer cause anything that comes after. So that fundamental principle of Buddhist metaphysics basically breaks down. And that is not something that would be reconciled with a theory. And so the idea that there is dark energy and that there could cause a universal bounce, the idea that is necessary for loop quantum gravity and the foundation of the universe, which I will explain why this understanding is necessary for its creation out of a quantum particle, is that there would have to be a collapsing universe in order for a big bounce to happen. And so how could that collapsing universe be created? Well, it'd be created at a point where dark energy was not powerful enough to overcome something, which means that the changes can be in flux and that there is potential for those changes to be in flux, and that if we are taking an understanding of a certain level of the specificity of universes, that, not going back to what the 4 different levels are, but essentially that the same laws of physics apply, that it's also possible for dark energy to be in flux in this universe, and that a similar thing could happen. And I think, again, there's an element of hubris and understanding in believing that there is no reason for the same principles to apply in this universe in which we live, and that it will essentially be the end, will signify the end of dependent origination eventually over time. And that there is an infinitely low likelihood that we exist as we do right now. So it's not even just a matter of disparaging, personal qualities like hubris. It's just that it's mathematically virtually impossible which is why I said an infinitely low likelihood. Although then, of course, there's always the idea that if there's quantization of the universe and the universe is finite, and at a certain point there are no longer any forces acting on it, and it's at the big freeze, that means that there will be no time passing, which basically means that it's tantamount to a specific time, which would mean that, for all intents and purposes, I mean, nobody's going to be experiencing that because all the particles are going to be frozen, they're going to be completely still, and they're going to have finished decaying, essentially. They're going to have decayed into their final form. That means that it will be the end of time, for all intents and purposes. Because there will be no basically measuring stick or anything left to understand it by. And so this creates some interesting implications. But going back to the idea of loop quantum gravity, there's a specific reason why it stresses that there's a big bounce, which has to do with the energy density of the universe, also the curvature that's created for the universe, for everything to exist, but especially the tension which is exerted, if I'm using that term correctly. I may not be using that correctly, but the general idea that there is some sort of tension exerted on the universe by the particles that are contained within it. Or if you use the monistic view of loop quantum gravity, which is something I was describing earlier, that there is only really one ground. It's not like there is, matter in the space it inhabits, but that matter is a fundamental property of the kind of network of space, or some reorganization of attribution of certain information to particular loops, or IIs as I call them, which at that point, again, it's just like a matter of changing vocabulary. If you want to frame them as particles which are occupying a certain position, or if you want to frame them as those specific loops which exist inherently and cannot really be created or destroyed, are just imbued with information, and the fact that they exist, if you want to get into the semantics of this, the fact that they exist doesn't change. Their position is something that may be in between, but the quantities and qualities of their existence are continually in flux. And so not going into the idea of conformal cyclic cosmology, which would necessitate that the universe is infinite, because that would interfere with the theories that were espoused earlier. There's this interesting kind of loophole that connects the concerns of a finite universe and an infinite one, and this is what I'm about to approach. So first of all, this loophole of the finite but open-ended universe has already cleared up the issue, as I've described, of the universe seeming to expand in all directions at the same time, which is that if it is expanding towards the edge of the universe, then it is also expanding inwards towards itself, because everything that comes through that edge certainly eventually re-enters the universe basically on the other side, but everything is also leaving at the same time, which would give you the impression, no matter where you are, I can't speak to the exact math behind this, but essentially that it's possible that everything could be expanding away from everything else in this finite space, but an open-ended space. Again, so that's not exactly easy to visualize within 3 dimensions, but if something had extrinsic curvature, which is curved into the 4th dimension as a principle of originally 3-dimensional space, then it may not be considered Euclidean. It might be considered a form of spherical geometry. So the interesting thing is that at the same time, somehow space is considered to be flat, but open-ended. So there are 3 principles we're discussing. The first one is whether the curvature is extrinsic or intrinsic. The second is the form of the curvature, whether it is defined by the particles in the universe and the impact that they have on the space which surrounds them, or whether it is just a fundamental property of the geometry of the universe. And the third is whether space, even if it is flat and has 0 curvature, is open-ended or closed. And I think the general consensus for a lot of this is open-ended, because it solves all of these issues of infinite space. It allows for there to be the idea of infinite space, and the mathematics necessary that something could, in theory, expand infinitely, given an infinite amount of time. But does not necessitate that there is an infinite amount of information in the universe. There could be a finite quantity of information in the universe. And I think this is very important to understand when it comes to theories like loop quantum gravity, that there is an incredibly vast but still finite amount of information in the universe. And of course, this is something that diverges. So when I'm thinking about the universe expanding and contracting, this is getting down to the final point. The idea that the universe is contracting, if there was an idea of a collapsing universe, we're just using the conditions that apply to that and saying, we're supposing essentially that those same conditions can apply to the end of this universe that happened before the last big bounce, which we would consider to be the Big Bang. Supposing that those same conditions are possible, it would mean that that the universe can kind of keep expanding and contracting. But my initial understanding was that it would be caused by a particle which was decaying into another particle or moving in a certain direction, and then eventually maybe interacting with those particles, and its descendant particles interact with one another, and it kind of causes this continual tree of universes which branch out. But it doesn't create a solution for how they would kind of branch in again, And so one idea is that eventually after a certain point, all these universes exhaust themselves, they all wind up in a big freeze, and that nothing is happening in any of them until the last one is there, and there are no longer any universes, because like I said, time in the big freeze, saying that all the particles, there are no longer any quantities which can be said to exist and have attributes that are inherent to those loops, which is the interesting deviation between Buddhism and loop quantum gravity, which is the idea that there is no self, or that there are no absolute qualities which are inherent to the thing in itself, and the loop quantum gravity theory that at the fundamental Planck level, there are specific quantized values which could be attributed to this. Now, this is a very satisfying conclusion because it allows for the idea that, yes, at a larger scale, there is nothing that make classical concepts or social concepts of the physical nature of reality hold any water whatsoever, and they're completely based on mental constructs, but at a subatomic and ultimately at a Planck level, they are assigned specific quantized qualities which can match up with the contemporary understanding of physics and of reality. So it kind of reconciles both of those. But the problem is, one theory that I espoused in the original notes on my theories of the universe is that what is opening up and closing is not the universe itself. We can definitely define the idea of opening up from my original interpretation, which is before my understanding of loop quantum gravity, but not the idea of closing. And so one explanation for this one that I posited in that addendum to the discourse was that it is not the specific universes themselves which are opening and closing. It's not like at a certain point there's just a natural symmetry that is not based on what came before it, and is an inherent principle of the geometry of time, which basically argue that it would necessitate some kind of time travel or some geometry which fundamentally doesn't make any sense, because it would mean that the universe kind of almost knows in a sense that it has to close up at a certain time, and that there would be like a column like in the middle of a hallway, and then the midway point in between the universe and that column would signify that the gravitational forces are reversing, that maybe dark energy even itself is turning off, and that the universe can now collapse. Now, this creates several problems, but the main one is that it's not based on any historical events which happened or any logic which is determined by induction or by the cause of events we have observed of the physical universe. And so there is no reason for this to exist. So one theory that I explained to solve this problem is essentially that what is expanding and contracting is not the physical universe itself, but the potential for a certain number of universes to exist at any given moment. Like I said, at a certain point, maybe once they exhaust, and this is just a very temporary theory, that is not, this component of the theory is very temporary, and it's not necessary for any broader understanding. There might be a much better explanation. But the temporary explanation is that at every big freeze, there is essentially time stops for every universe. And that means that the universe functionally doesn't exist while the other universes continue, because time is still going on in the omniverse, which is kind of this register of all the different universes that are going on, because time is still continuing between all the different universes that exist. But that does mean that every time the universe ultimately hits a big freeze, that the number of universes is decreasing. So this is interesting because it means that there is a form of contraction that is happening, but it is numeric and not spatial. And it pertains to the omniverse and not the universe. And that essentially once this reaches 1, the tension will be so great, because this is the understanding of loop quantum gravity. The explanation of loop quantum gravity differs most fundamentally from my understanding of it in the most irreconcilable way, in the original sense, which is now something that I no longer need to adopt if this is the established theory. But my understanding was essentially that there's kind of one particle at the beginning of the universe and that it multiplies outwards. Loop quantum gravity believes that loops cannot be created or destroyed. They just exist, but they can expand and contract. And essentially once they get down to a certain density, there's a certain density of information in the universe that it cannot hold anymore, especially when it's collapsing. And then it's like a spring, and it has this potential energy. It needs to spring outwards. That's just a fundamental property of it. It needs to, and eventually that force is going to become so strong that it overcomes the collapsing force and it springs outwards. And that's kind of what caused the Big Bang, what's caused the big bounce, is this need to spring outwards. And so that will happen with the densely packed matter. But if we're understanding that there is a big freeze, then there is no reason for this to happen at any point, unless there is the Higgs field, which overcomes the idea of dark energy. Now, this is a good way of reconciling it, that essentially there is a false vacuum, and that right now, the way that it appears with dark energy is accelerating in the universe. There are these certain quantities, or I should say quantities associated with different metrics in different particles, and that each of those qualities are inherent in the universe to a degree. And that degree is entirely predicated on the current state of the Higgs field, which is subject to flux. And when it does ultimately change, which could be an extremely inconceivably long amount of time, it will, quote unquote, rewrite the rules of the universe, rewrite the rules of physical reality. So this poses some problems, but for the current understanding and the idea of dark energy, but it does reconcile the idea that even though dark energy does appear to be ripping the universe apart right now, it's possible that in an inconceivably long stretch of time, the Higgs field that still exists will change, I would say independently, because, and not independently in the sense of it exists apart from everything else, but it is kind of the index upon which all of the other physical matter in the universe is predicated, and that it will change, which would allow for something like a big crunch to happen. So that's one explanation. Another one, like I said, is the idea that if I'm talking about this energy density, it is almost as if all of these universes kind of have their own breathing space. There's a need for the information, for the quantum tension that is packed into one universe, that is, even if it's still all of the loops that will ever exist in the universe, because they can't be created or destroyed, they're packed into an incredibly small amount of space. and there's a lot of tension that's happening between them, it needs to expand. And so it will expand in the sense of particles, happening there, different particles that form, and they kind of get consolidated into larger particles, and the universe expands spatially. But also that for every one of these chances that can happen, it also expands potentially. And that the potential of all the different universes which expand is something that is an expression of kind of letting go of that tension, and letting go of what was pent up before within each universe. And so this would be a way of resolving some of that tension, but also eventually, once it gets to a certain point, there is less and less information after that tension has been exhausted in each universe. Once it gets to a big freeze, once it has finally run its course, all the universes are kind of just sitting there, taking up space without, and they're only being held together by the few remaining universes in which there are things happening, which are the few universes that give a sense of time to the omniverse. And all the other universes are kind of held in suspension, even though nothing is happening in them. And so it is this point where the tension starts to reemerge, and that eventually it comes down to one universe where there are still things going on. And from that one universe, it'll be so tense because it's taking on the tension of all the other empty universes where there has already been a big freeze. And that from that universe is what there will need to be new things to happen. And this doesn't require the immediate destruction of big freeze universes, the other ones that are there. And again, it could just be a matter of semantics, because you could say that if there's no longer any time occurring, there's no longer any fundamental matter, or specific particles which could exist. There's no longer a specificity which defines that it exists anymore outside of a void. So it doesn't need to be magically destroyed or anything. It can just say that functionally it doesn't exist. Or, again, using the model of the bell curve, it could be that that universe is so unlikely at this point that due to the quantization of probability that would arise from this interpretation of loop quantum gravity, that would be that the universe doesn't exist at that point. It kind of almost just functionally, it appears as if it deletes itself because its probability is so low that it's no longer necessary. This scaffold model of the fourth level of universal specificity, which would destroy the many worlds interpretation and kind of result in this idea instead that our universe is the only one which exists, would allow for that to happen without creating any other issues. But one other explanation that I had, and this is one of the most profound insights I think from this section of the discourse, is that upon understanding the idea of an open-ended universe, once the potential of all universes is expanded, it doesn't necessarily rely on the abstract theoretical principle of the tension being housed across the universes in an omniverse to, bounce out again, to spring out, to, expand. It doesn't rely on taking all that tension and kind of have an exploding point. It might just rely upon the inherent open-endedness of a finite universe itself. Because, think about it, say that there is some particle that is in a finite universe, and even if it's only one particle, or say like a loop, for example, even if it's only one loop, or space is open-ended, that means it would exist in an infinite grid, a three-dimensional grid, which would be created, essentially. Now, it would look to us as a three-dimensional grid, but it would really just be this one loop expanded in an open-ended universe and kind of curved into 4 dimensions. That would look as if it's recurring infinitely, but really just be the same loop, but curved in on itself in 4 dimensions, so curved extrinsically. And the pressure and tension of all of these iterations of the same universe together, the same loop, all compressed within that one, no matter how long the time frame, would be enough for it to need to expand. And so I don't know how that would play into the specificity of how each universe would go down a different route or a different path, but it basically does provide the idea that it may just be a principle of an open-ended but finite universe, that if it is open-ended and it is extremely dense, there is only one particle and all of space is kind of packed by one particle, because this might be reconciled with the previous theory of the idea that it's the potentiality of universes, because it may not even need to be that it is because all of these empty universes are sitting around that this one universe kind of in a way feels the tension and needs to bounce back or needs to expand. It might just be that there are all these empty universes sitting around, but in the few that do exist, the tension is down to very few particles, which consequently have massive implications for the remaining fate of the omniverse. And that implication means that they have a lot of power, and there's a lot that's stored in those few remaining particles, and that these few decisions mean that even if there are all of these different potential universes that exist, that those particles would contain the tension that is necessary. Again, if you visualize it, no matter how the loops are, if this is impacting an entire, spin network within the entire universe, then it is impacting what would appear outwardly to be an infinite expanse, even though it is just a recurrence of one universe curved into 4 dimensions, continuing onwards in every in all 3 dimensions, and repeating itself. And because those would be packed so tightly, it would appear to each universe from the inside that they are packed in a bunch of universes that appear just like them, very tightly. And this would have the same effect as having an infinitely large, single, closed-ended universe that was packed tightly. So at that point, it might even just come down to almost a matter of vocabulary difference between the two. Because again, on one side you have, at this nexus point of the big bounce of an infinitely large universe with infinitely many loops in it, and they just all packed extremely densely, or a finite universe with a finite amount of loops, but they're packed in such a way that they continue essentially ad infinitum, for lack of at risk of overusing that phrase because it applies here. But it does, I said almost a vocabulary difference, because that is certainly not, and because there is one thing that is completely cleared up by the interpretation that it is an open-ended universe. And that thing that is cleared up is that there is a finite amount of information that's stored in the universe, and that it's finite in size, and that it satisfies basically all the requirements necessary for both theories. And so that universal expansion and contraction predicated on the idea that, omniversal expansion and contraction predicated on the idea that the tension based on the universe is not stored solely in the loops of one universe, but could also be based on, in the many worlds interpretation, the potential of all other universes existing even once they reach a big freeze, which would essentially mean that there are almost these empty universes, and that the remaining universes, they could almost not be taken into the equation, but the remaining number of universes in which there's activity is incredibly small, and that the end result of that is that there was a lot of tension on those universes, and once that reaches down to a certain critical point, that it is completely immediate that all of the universes around them are experiencing things in the same way, and the tension exerted by each loop on the loop around it results in the need for a big bounce. So I hope that clears some things up, and I don't really know what to call this right now, and I'm probably just going to end up calling it Notes on My Theories of the Universe Part 2, because that's really what it is. And I think that not only may this be a successful continuation and a secondary addendum to My Theories of the Universe, it may bridge the gap between Notes on My Theories in the Universe and future discourses, should I create them, concerning some serious topics in cosmology, now that so many of these ideas have been consolidated and reconciled with existing physics. So yeah, I hope that clears things up. As again, thank you for listening to this.